Today, we are going to learn about the quadratic formula. The quadratic formula, first of all, most important concept is it has to be in standard form. So if we take a look at this template that it is, there's a couple things that we need to notice. First of all, it's in quadratic form, x squared, x, and then my constant. But what needs to be observed is that, here's the most important thing, it needs to be set equal to 0. And we remember that when we were factoring also, that everything had to be set equal to 0. But we don't pull our a's, our b's, and our c's until it is set equal to 0. So we're going to pull out the a value, we're going to pull out the b value, and we're going to utilize the c value when it's in standard form, and it's not in standard form until it is set equal to 0. Very important. So this formula is you're solving for x. You're going to get your x value, and that's going to be provided by the opposite of b plus or minus, that's a plus or minus sign, the square root of b squared minus 4ac all over 2a. So let's see, what does that mean? Well, we're solving for this equation. And remember, we go through a whole bunch of things prior to this. This is a method of solving. So one of the first ways is you look, is it in standard form? Yes. Does it have a common factor? No. Is it a special case? No. Right? Is it a binomial square? Is it the difference of squares? No. And then 4 is a times c. Now we're not going to do a times c because this actually does work. We could factor this and then use the 0 property of multiplication. But remember, when we couldn't do it, when a times c, when it didn't equal my middle value, we'd say, unfactorable. But that next step is not unfactorable. The next step is quadratic formula. So we're going to utilize the quadratic formula. So the first thing in utilizing the quadratic formula is we have to find our a, b, and c. My a is going to be 1, my b is going to be 9, and my c is going to be 8. And now we're going to use this formula to solve for, it says x, but because my variable is v, we're really solving for v in this case. So it says v equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times my a value. We're okay with this? I'm going to move all this over to here, and I'm going to move this over, and we're going to start simplifying. So we have to simplify inside the radical. We have to simplify this radical and all the things inside it before we take the square root. So we're going to square 9 because exponents come first. So v equals -9 plus or minus square root. 9 squared is 81. Minus 4 times 1 times 8. And now we do it over 2 times 1. Yes, we can simplify some of that. -9 plus or minus 81. Now what is -4 times 1 times 8 is -32 over 2 times 1 is 2. -9 plus or minus 81 minus 32. That's going to be 49 over 2. What do we notice? Yes! It's a perfect square. We love it when it works and is nice and clean. So we get -9 plus or minus 7 over 2. Now, this is where the new idea comes from. So we have to do the plus or minus. So we do -9 plus when 7 is positive, and we do -9 when 7 is negative. Let's move that stuff over and give myself a little bit more space. Well, give myself a little bit more, space. Space? Oh, board. The smart board's driving me crazy. Oh, that's not good. Let's save. Does that help it? Oh, please don't bonk out on me. Can I write? All right. Equals, all right. That's going to be negative 2 over 2, which equals negative 1. And negative 9 minus 7 is negative 16 over 2, which is negative 8. And those are my v values, x value. Ooh, hello. Those are my v values. So v equals, and we can do it in a solution set, negative 8 comma negative 1. Those are the solutions to this equation that makes this left side equal to 0. If we plugged in negative 8 and if you plugged in negative 1. So again, since the variable in the equation is v, my solution is going to be negative 8, negative 1. Let's try another one. So first thing we do, is it set equal to 0? Yep. Is it in standard form? Yep. So let's pull the a value is 2, the b value is negative 5, the c value is negative 12. Now let's utilize the quadratic formula. We again have v. So v is going to equal the opposite of b plus or minus the square root of b squared. I'm going to have parentheses because my b is a negative, so I want to include it when I square it, times 4 times a times my c value, all over 2 times a. And I'm getting that from this equation. All I'm doing is plugging in the b's, the a's, the c's, and the a. That's where I'm getting this from. Okay, so it's not just coming out of ether, it's coming out from that. So we have the opposite of negative 5, which is 5, plus or minus the square root. Negative 5 squared is 25. Negative 4 times 2 times negative 12 gives me positive 48 doubled is 96 plus 96 all over 2 times 2, which is 4. So we get 5 plus or minus the square root, 25 plus 96, 121 over 4. We love it, because 121 is a perfect square. And now we're going to separate them. We have 5 plus 11 over 4, and we have 5 minus 11 over 4. That's what the plus or minus means. It means we're going to deal with plus 11 and negative 11. 5 plus 11 is 16 over 4, which gives me 4. 5 minus 11 is negative 6 over 4, which is negative 3 halves. So those are my two solutions. V is going to equal, there's my solution set. I'm going to put them in numerical order. And I get negative 3 halves comma 4. Again, those are the only two values that we can plug in for v to make it equal to 0. Those are the solutions. Typically, it says equals y. So we can also, because y right now is equal to 0, we know that not only are these the solution to this, but they're also the x-intercepts. That's above and beyond. All right. Oh, whoa. What do we notice? We notice that it's not in standard form. So my r squared, whatever my squared value needs to be positive, and it is positive in this, so I'm going to move everything else over here. So how do I get rid of the negative 11r on the right side? With a positive 11r. That gives me 4r squared plus 11r equals 38. How do I get rid of that positive 38? By subtracting 38 with a negative 38. And that gives me 4r squared plus 11r minus 38 equals 0. Now it's in standard form. It's set equal to 0. Now I can pull my a, b, and c values. A is 4, b is 11, c is negative 38. Oh my goodness, that's got to be a huge value. And we're not solving for x, we're solving for r. So we get r equals the opposite of b plus or minus the square root of b squared minus 4 times a times c. Oh my goodness. I'm going to need my calculator. And 2 times a. A is 4. So we get, let's just partition that off. Negative 11 plus or minus the square root. 11 squared is 121. Negative 4 times 4 is negative 16. And negative 16 times negative 38 gives me positive 608. I have a negative times a negative times a negative times a negative times a positive gives me a positive. That's why I knew it was positive. All over 2 times 4 is 8. I have negative 11 plus or minus the square root. 121 and 608 is 729 over 8. Is 729? 729. Is that a perfect square? Yes, it is. 27. So we can do that on the calculator. 11 plus or minus 27 over 8. Let's do negative 11 plus 27 over 8. And let's do negative 11 minus 27 over 8. That's going to give me 16 over 8. That's nice and genteel. And this is going to give me negative 38 over 8. Not so genteel. But we can reduce it. Let's divide by 2, which gives me, right, did I do that? 38? Yep, that's good. That's going to get divided as 9? 14 ninths? 19 fourths? Negative 19 fourths? Is that really the answer? Oh, I don't even have the answer key. Negative 19 fourths. It feels heavy. Feels heavy. Let's see. Hold on, I think I have the answer key. Quadratic formula worksheet. Oh, what number was that? Oh no, that wasn't the worksheet. Oh, I didn't even save it. Oopsies. I didn't even save the answer key. That wasn't very smart of me. Okay. That's got to be it. I'm trusting it. You'll let me know if I did it wrong. So I think the variable is r equals the solution set. We're going to do it in numerical order. And those are my solutions. I could check. I could plug in and make sure. I can also go over my work and make sure I did it correctly. But the fact that it ended up being 27, that's pretty good. 27, yeah, 27. So I think we're all right. I'm going to trust it. You'll let me know if I made a mistake. Come on. Did I skip 4? Yes, I did. Ooh, look at this. All right. It's not in standard form. Let's move that 25 over. Let's set it equal to 0. Now, what's my a value? My b value is the coefficient of x. I don't have an x, so my coefficient is 0. And then my constant is negative 25. And hey, we actually have a variable x. So x equals the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. We have 0 plus or minus 0. Negative 4 times negative 25 is positive 100 times 4 is 400 plus 400 over 8. We have 0. Well, we don't even have to do it because 0. It's just going to be plus or minus 400 over 8. That's inside. This is outside. We can't simplify those two radicals. We can find is, can we simplify the square root of 400? Yes, we can. Let's do some good remembering math. We just finished radicals. So we have plus or minus. I'm going to make this rad 4 rad 100 over 8. Rad 4, square root of 4 is 2. Square root of 100 is 10 over 8. And we get plus or minus 20 over 8. And we can reduce that to 10 over 4. And we can reduce that to 5 over 2. So my solution, you can write this two ways. You can write x equals plus or minus 5 halves. Or you can write it negative 5 halves, comma, 5 halves. That's what plus or minus represents. I'll take both of those. I'm 100% confident on that one. That was a good one. Is it in standard form? Is it equal to 0? Nope. I got to set it equal to 0 by subtracting 21. A squared plus 2a minus 21 equals 0. My a is 1, my b is 2, my c is negative 21. And this time it's an a, so a equals. Different a from this a, those are different. My a in this are my coefficients in standard form. This just happens to have the variable. The equation was set equal to a. So a equals the opposite of b, negative 2 plus or minus the square root of 2 squared minus 4 times a times c all over 2 times a. A equals negative 2 plus or minus 2 squared is 4. Negative 4 times 1 is negative 4 times negative 21 is positive 84 all over 2. Negative 2 plus or minus, we got 88 over 2. I cannot cancel these at the moment. This is a good time to stop. I cannot cancel those. I cannot simplify them because it's being added. Can't divide when something's being added, so not yet. Let's simplify this rad 88. So rad 88, I know that that's 4 times 22 over 2. And that becomes negative 2 plus or minus, rad 4 is 2, rad 22 over 2. Rad 22 cannot be simplified. There are no factors that are perfect square. But this time I can cancel all of these. As long as I can do it to all 3 pieces, that's okay. But what are you left with? Negative 1. They don't make 0, they make 1s. Plus or minus. And we don't need a 1 in front. We don't need to write 1 rad 22. We can just write rad 22 over 1. And we don't need it over 1. So this is my solution because I can't simplify. So I would write that, what's my variable? A. A equals the solution set of negative 1 plus or minus rad 22. Or you could have written negative 1 plus minus rad 22, comma, negative 1 plus rad 22. Both solutions are correct. Notice it's negative 1 for both of them because that doesn't have the plus or minus. The only thing that gets plus or minus is this. That plus or minus is attached to the rad 22, not the negative 1. That's a good one. Oh, that's it? Wow, that was kind of quick and fun. All right, so that is a whole bunch of different examples that you will see. We went from vanilla with my already set up in standard form, and then we started messing around where it wasn't set equal to 0. So when we have these problems for homework, you'll have to recognize which
Which one are they? Good luck. Have a great Friday. I will see you on Monday.